The recording.
Oh, this is funny now that she's right in front of you, so we're just gonna see. Kenzie, stop. Kenzie, think before you answer.
Just sit down. Don't trip over that cord. All right. So, ooh, don't trip over that, Doja. That is definitely 35. The region on or above the x-axis bounded by the curves y squared equals x plus 3 and y equals 2x. Say the square root. So y is the square root of x plus 3. Yeah. Okay. Square root of x plus 3 is moved to the left 3, right? Is this this is a calculator actually, but let me show you. All right, think about that parent graph that's just been slid to the left 3, right? I'm just kind of trying to get a feel of what's on top, what's on the bottom, and what I need to subtract from what. So there's the first graph. And technically you do the plus or the minus, you'd have this bottom part, but because it says it's bounded by the x-axis on or above the x-axis, I don't need to worry about anything on the bottom. So now I'm going to do the y equals 2x, which just goes through the 0, 0, and a slope of 2. So something about like that. So my area that I'm looking at to integrate here looks like that. That's the shaded area that I'm looking to find, yes? Yeah? Very good. Okay. So I think Logan, where's Logan? Is this the one this is not the one we were doing yesterday. Oh, that's what you were saying. We didn't have to. Okay. We did do this one in class? I need a calculator. All right. Yeah. Where are all my calculators right now? Like, there's 4 on your desk. They're dead. All of them are dead. All right, we're ready to take it. I'm going around with them. It's dead. Oh, sure. All right, square root of x plus 3 and 2x. All right, listen. You can't just do top curve minus bottom curve all the way over here. If you did top curve minus bottom curve from here to here, what happens is you end up including this area in it, and you don't want that area, right? Because it says from the x-axis up. So I have to divide this into 2 different areas. I'm going to do the integral. I'm going to do this one first, which is going to be the integral from -3 to 0, yes, of this function, because that takes me down to the x-axis. So of the square root of x plus 3. But then I'm going to add to it, this is what you were saying, right, Wyatt? That's what you did. I'm going to add to it the integral from 0 to 1, because this point ends up being something 1. X equals 1 here. And this is where I have to subtract them. So I got square root of x plus 3 minus 2x, right? And so now, if I've done it correctly, because the second one, so this is my x-axis, right? The first one takes it just, the curve sits flush on the x-axis, so it'll take it down to the x-axis. But for this one, I've got like this extra space that I want to take out. So I have to do, this is where I have to do top minus the bottom so I can get the white part there. It didn't give me a picture, it just gave me 2 equations. So I'm going to show you what it looks like on your calculator so that you know, since this is a calculator problem, you kind of know what you're... Miss McGee, what? I don't think so either. All right, here's the 2 of them together. So if I were to calculate from -3 to 0 on this function, this is what it's going to give me, right? That's only using that square root function. And so I get 3.46, da, 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 da. But you see, if I kept it going to 1, let me show you what happens. Now watch where this line is right here. If I keep this going from -3 to 1, I end up with this extra space here shaded that I don't need. So that's why I can't do it that way. So instead, I'm going to come in. So I'll do math. I'm going to do, I think I have, yeah, y1 is my square root one. So I'm going to do y1 with respect to x from -3 to 0. There's my first part. Now to that, I'm going to add, I'm going to say plus, and now I'm going to do the integral, and this is where I'm going to do my top minus bottom. So y1 minus y2, are y'all following me on this? X, and what am I running it from? 0 to 1. 4 1/3, 4.33. Did you do the same thing I did? Did you say plus after that? Like to add them together? Yeah. That takes the 3.4 whatever and adds it to this next operation. Does that make sense? I really want y'all to get used to using your calculators for these kind whenever you can. All right, what else on your homework? Liza, you feel so far away. 41. I miss you too. You're always my backup. Y'all leave Mr. McGee alone. All right, 41. Oh.
Hey, I got 39.
Okay, 39 then. 39 and then 41. 39, find the area of the triangular region in the first quadrant bounded on the left by the y-axis. What's that mean? It means I'm starting the integral at 0 because the y-axis is going to bound it. Is that one sine or cosine, and how do I know? Why? Does cosine start at 0? What's the cosine of 0? This is sine. This is sine because what's the sine of 0? But you have to know at least that. Okay. And this one. Okay. Okay. This is the one I'm talking about, right? So this up top now is cosine and this is sine. Isn't that what it's saying? Wait, let me read. It might not be that one. Wait, yeah. Bounded on the left by the y-axis and on the right by the curves. So this curve and this curve. So first thing I need to know is where do they intersect? And you could actually know that pi over 4. But you should know that. What do they share? Because the only place where they have the same exact coordinates, where they are the same, where they equal, is pi over 4, because that's square root of 2 over 2 for that one. All right, so this is pi over 4. So what I'm doing is the integral from 0 to pi over 4 of, which one goes on top? Cosine x minus sine x. You could actually do this without a calculator, but the antiderivative of cosine is sine. The antiderivative of, so it's going to be plus cosine. I'm going from 0 to pi over 4. So I feel like we did this one. Sine of pi over 4 plus cosine of pi over 4 minus the sine of 0 plus cosine. I swear we did this one. So here's the problem, and why I'm really working through this one by hand, even though you could have used the calculator on this one, is because with these being some nice values here, it makes it really easy to calculate by hand. This would be one that they would put on a calculator section, but the answers choices they give you would be an exact form. So in other words, the answers that would look, if they've got 2 of these, are a half of a square root of 2 and a half a square root of 2 gives me a whole square root of 2 minus 1. This is what the answer would look like. Or you could test each one, yeah, if you have to test one. I don't know how they did theirs exact too. But anyway, there's that one. What else? We did 37. There's 37. Cubed root is on top. Instead of doing it twice, since guys, some of y'all are having a grand time, Dozier. Instead of doing it twice, Kenzie. What are we talking about? All right. Instead of doing top minus bottom, doing it twice, since it's symmetrical, I just times it by 2. So I did this one twice, and it's calculator. So there's my equation. Does that make sense? All right, 41. Okay, I'm going to move you. Kenzie. The region bounded below by the parabola y equals x squared. Well, at least it's about math. And above by the line y equals 4. No, we did this one too. Joel, oh, it's very similar. It was y equals 2 instead of y equals 4. Okay. This is y equals 4. Partitioned into 2 subsections of equal area by cutting it across with, ooh, this is a good one. I've seen an FRQ like this before. sketch the region and draw a line y equals c. So I've sketched the region, right? Here's my region. I'm going to call this region R. And it says to create a line horizontal that cuts it in half, right? It doesn't have to be exact. They just want you to be able to visualize this. So I'm going to call my line y equals c, and I'm going to put it about where I think it's going to cut it in half. It doesn't matter. The point is it could be anywhere. It's this arbitrary line y equals c. Okay? Now let's answer the questions. Arbitrary. Kind of like anywhere. Like whatever, like arbitrary, random. Like. In terms of C, what are the coordinates of the points where the line and the parabola intersect? Kenzie. Okay, don't do this. You need to move back more. All right. How do I tell where two things intersect? Set them equal to each other. So I'm going to set this and this equal, guys. It says, where is the line intersecting the parabola? So x squared equals c, which means x equals plus or minus square root of c, yes? Which means that this point, now watch what I do here because I need a coordinate. If the x is the square root of c, what is the y value here? C. Right. No, yes, and because it sits on that line. Now, this one, negative square root of c, c.
Hey, that's what the book told me, and I wrote it down.
All right. Add them to your figure. Done. Calculus book. Part B.
Yes, I did my homework.
Kenzie. Find C by integrating with respect to y. It puts C into your limits of integration. Okay, you can't do B, but you can do C.
No, C and B are the same thing. They got the same answer according to the book.
You will get the same thing. Today we're talking about integrating with respect to y. All right, so first of all, before I do anything, can you find the area of region R? Yes, you can. What is the Logan?
It's top minus bottom.
Okay. Logan, do not mock me. I'm used to being. All right, let's rewind just a little bit and let's find the area of region R, okay? Logan, if I asked you to find region R, tell me what you do.
I'd probably integrate.
Integrate from what to what?
I'd probably go to the
Give me the bounds of my integral. Not with the C's, I'm talking about the entire region R, the entire shaded region.
No, it's 0 to 4. For the entire region of R. Oh, my bad.
Why, Slade? Why is it negative 2 to 2? That's where these are intersecting. I'm going from here to here. Okay? Because I need to know, where does x squared equals 4? I'm doing it my way. Well, I'm finding region R right now. Just watch, just watch. You could also go from 0 to 2 and double it. Okay. All right, now I gotta do top minus bottom. Shh. Y'all, what the heck? Give me an amount. Give me a value here.
1.
What is the integral from -2 to 2 of 4 minus x squared?
2.
4x.
I hope one of you is at least typing this into your calculator or something, because I don't think y'all know that unless you're doing it by hand. Oh, 10 and 2/3. 32 over 3. I'm not there yet. I'm not at the answer. Now, 32 over 3 is this entire area here. No. What I'm doing, I'm going to set up an integral. I'm going to cut it in half. You're exactly right. I'm going to cut it in half and then set it equal to the integral from here to here. Well, that's not my, that'll tell me how much area is in half, but that doesn't solve for C. So if this is region R, right? Let me get another color. You could have, but I want you to see why. I'm trying to make you see why. Okay, so 32 over 3, if I do top curve, which is all of this, minus the bottom curve, which is this little bit here, and I take that out, I'm left with this R in the middle. That's my entire R. My entire R is 32 over 3. But what it tells me is that line I drew, that C line I drew, cuts that in half. So half of that would be what is that, 16? Okay. Now, 16 over 3 is the area. It's the area of what? 16 over 3 is the area, half of the R, but using a C because I'm trying to solve for C. If I run my integral from negative square root of C to square root of C, oh my gosh, let me finish. Watch, watch. And I am doing top curve. What's top curve? C minus the bottom curve, x squared dx. Now, antiderivative it. And it's, what's it got to equal? What's it got to equal? You're going to have a C in your answer. It's okay, but I'm solving. Okay, well, it might go away. Just wait, let me see. Because the area, this area right here, is half of R. So I found R and cut it in half. Yes, 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 yes. I have not taught you integration with respect to y yet, which is why I'm doing it this way right now. Okay. But yes, because it is symmetrical. Okay. Cx minus 1/3 x cubed. This is all evaluated from negative square root of C to square root of C, and I better get 16 over 3 when I'm done. I'm going to plug in top bound minus lower bound. C times the square root of C minus 1/3 square root of C cubed minus what? What is common on the AP exam would be set up but do not evaluate an integral that lets you find C. I've not seen any where you go through solving from there. I would see set up but don't solve.
It'd be like, yeah, this is.
Yeah, I can find a value for C because this is a calculator problem. In all honesty, what I would probably do. No, I'd clean it up first. I have two of these. If I have my calculator, this goes in Y1, this goes in Y2, and I calculate an intersection to find the value. You don't have an X in there, you only have a C. So put an X in your calculator. So I do 2x square root of X. Let's see if I got it right. 2/3 square root of X cubed. I'm scared to say this answer out loud. I just did this, and then I put a parenthesis with a third. I calculated the intersection. Is that what they got, Logan? Logan! Is that what they got?
They got 2 4/3. No, that's not right.
Yes, it is. It's right.
It's 2.51984221.
Cutting close.
It's right.
No, it's not.
You just don't want to rework it.
I don't. Okay. Where? No, it's not. Oh. This is actually canceled out. Because that's positive and that's negative. That's not there. That's why. Oh, I see what you're saying. This is minus. Okay. Fine. Still a 5.
Like, I can't do this. You're giving us problems.
Give me another. Oh, that was all the homework questions, right? Okay, let's move on. What's today? Thursday. That was a fun one. It was frustrating, but it was good. Well, then you're going to think today is thrilling. Last day on integration between two curves. You're welcome. We're behind.
Wonder why.
Always behind.
No, we've been ahead. We've been ahead. Now we're behind. All right, integrating with respect to y. Bro, what? I'm fixing to show you. Yeah. Right minus left. I always forget this. This is when your equation is solved for x instead of y. Okay? No. This is when your equation is solved for x instead of y, and you find it easier to find the area to the y-axis instead of the area to the x-axis. So whereas when we're integrating with respect to x, we take the area from the curve down to the x-axis. This time it takes the area from the curve to the y-axis. And no, well, you could just to show that you get the same answer. So, yeah. So here, whereas before these have been x values, now these will be y values. So it's where they intersect top to bottom instead of left to right. Now, what you have to remember, this is you know how we do top curve minus bottom curve? Okay. This is right curve minus left curve. Okay? If you remember that, you'll be fine. If you remember it's got to be solved for x, right minus left, my bounds are my y values and not my x values. Guys. Yeah, whatever, they're just y values, yeah. All right. No, it doesn't. Let me show you. All right, let me show you exactly what I'm talking about. Let's say I have the graph of, y'all got that already? The graph of y equals x cubed and x equals y squared minus 2. Now.
Wait, now we have to move it.
Okay, well then use your calculator. That's fine. Okay. You've got to decide which one am I going to be easier to solve for, x or y? Which one's going to be the better option? All right, were you done? So let's look at what each one of them looks like, right? This y equals x cubed. All right, y equals x cubed here. That one's easy. This one, not quite so much, right? But if I solve it for y, I get x plus 2 equals y squared. I have the square root of x plus 2, but remember how we talked about that plus or minus? And I'm going to put, so it's really just slid to the left 2. It looks something like this. Okay? And so what I want to do, we can integrate. Yeah, that doesn't matter. This is the area that. Right. So I could do this top minus bottom, but what I'm going to do instead is show you how to do this with respect to y, because some things lend them. This is an easy example to show you about the respect to y. So here's what I'm going to do. That's where they intersect. Which is what? Where do they intersect? Find it. It is a square root, but it's a positive and a negative square root. So this is one square root. This is the negative square root.
Why are we doing that? I thought we were solving this for x.
My
X
gosh. We are, but right now I need to know what this point is where they intersect. So Put it on your calculator then. Put it on your calculator and find the points of intersection. X cubed, square root of x plus 2, and negative square root of x plus 2. Okay.
It's showing us the way we do it.
I'm showing you how to set it up, and I'm going to show you. At the end of the day, we have to know where they intersect, whether we're doing it with respect to x or respect to y. When you graph it, it doesn't matter. It doesn't matter if you do it with respect to x or respect to y.
That's a really cool hook you got there.
No, he was talking to Dozier. I was doing her.
She's got her Kindle.
Like, we're on a break.
Okay, so it doesn't matter if I graph with,
That is not.
it doesn't,
It's literally PDF of the book.
Kenzie, just put it. All right. It doesn't matter if I graph with respect to x or respect to y. I get the same graph is what I'm getting at. So it doesn't matter. I don't know how to graph with respect to other, so I'm graphing this one because I know that. Does that make sense? Brother, I'm speaking from y'all's point of view. If I don't know how. Oh my gosh. Okay. In my calculator, I'm going to put x to the third.
Okay.
It's not a function.
X to the third.
Because everything in life's not functions.
What are we plugging in next?
Square root of x plus 2,
Okay, so
negative square root of x plus 2.
Right.
It's 3 of them. This is what it should look like. I can't do because it slows my computer down. Which it makes it drag and I can't even write on my error board. Software is not, I have too many things running. Okay. I need them all. That's what you should get when you graph it. It should look like that. Huh? Yes, yes. All right. I'm going to go and calculate my intersections so I know these points of intersection. I'm going to... $1.215. Remember that number. 1 point, what? What was the Y? Thank you. All right, and now calculate this one. What? It's even? Give me, is it in a whole number? It's... All right. Now we've got our bounds. We can write this in terms of y instead of x, since this one is already solved for x. Because I'm using it as an example. And because I couldn't do it, I can't do top curve minus bottom curve here. These are two different ones. If I just do square root, I have to do two different ones here because of the one on the bottom. So I got to just take, okay, I don't care. So x is the cubed root of y. That's what this graph is. This graph is x's cubed root of y. This graph is x equals y squared minus 2. Now I can integrate with respect to y instead of respect to x. So I'm going to take my right curve, which is the cubed root of y, or y to the 1/3. Because that's the one on the right. That's the furthest right, yes? Minus y squared minus 2. dy, what are the bounds? Look at the points of intersection and tell. Nope. 1.7, because these have to be y values. So these are the three things you have to remember with this. Brother. What are what things called? It's going to be minus, yeah. Because I'm trying to teach you how to do this one. I'm going to show you some where you have to do it with respect to y. But you couldn't do the x on here because if I did top curve minus bottom curve, right, what I'm getting here, right, it doesn't. All right, let me show you what it looks like on here. I'm going to show you. So whenever I get to ones like this, I will tend to just go into my main screen. Okay, and I'm going to pull up, integrate. And if you've got the fancy one that has the little integral, you're in a little better shape than I am. I'm just going to type that argument in here. So what was it? I'm going to use the x instead of the y. It doesn't matter what variable I'm using here because there's only one. So x to the 1/3 minus, yeah, with respect to x from -1 to what? Should be 4.215. This is just a variable in my calculator. And so, because there's only one, mine's still thinking. It should be 4.215. Is y'all still thinking? Okay. There we go. I know. It's old. If I am finding the, this number 4. If I am finding the area with respect, this time it's with respect to y, right? So I need to do right curve minus left curve. Right. So I'm going from 0 to 1 because I'm using my y's. It's already set up for me, so it's going to be 12y squared minus 12 cubed minus 2y squared minus 2y. But all this is actually a non-calculator. Brother, this one's easy. Your bounds are from 0 to 1, right? Yeah. But you see how you couldn't do top minus bottom here. I mean, what? Yes, yes. if they ask you to find the area between, if you ever have to find area between and your equations are solved for x, chances are you're doing it with respect to y instead of with x. So what does that look like? Well, that looks like, and let me just sketch this so I got it on here. I got this, and I got this. This is 1, this is 0. This one is 12y squared minus 12y cubed. This is why I can't have it hooked up. You see how it's writing? This one's 2y squared minus 2y. No, this is going to be just a straight polynomial. All right. So I'm going to do the integral from 0 to 1 of my right curve, farthest right. So 12y squared minus 12y cubed minus, and then I do my left curve. Put in parentheses, 2y squared minus 2y, dy. And now I can clean this up a little bit. From 0 to 1, I got negative 12y cubed plus 10y squared plus 2y. And now I'm ready to integrate. I take a 2 out, but you don't have to. 4/3. Now, some of them you're going to have are going to be in not really word problem form, but like in words, and they just give you the equations instead of the others. So let me see which ones I have for you to do.
What's the answer?
4/3.
Hey, that's what I got. Oh, this is my homework?
If you do the antiderivative here, so add 1, divide by 4, so that'd be negative 3y4 plus 10/3 y cubed plus y squared from 0 to 1.
So it's 23.
We did that one.
Yesterday was 23. Were we supposed to do the we should have done yesterday, right?
I don't have time to do all that today.
23.
Yes. These are all gonna, every one of these is set up to be easier to do with respect to y with respect to instead of respect to x.
That's why.
Yeah. What? Well, we just did 4. You've already done it. They should be 3, 7. 7 is calculator. Once you hit 7 is calculator. 8 is not, but that's really quick too. And 10. Once you get past 10, they're all calculator. Yeah, they're all calculator. All you got to do is set up the equation and plug it in your calculator. We already did 4. Yeah. Jelly bean. He said, you know what I mean? Jelly bean. Odd. They're all calculator. You just got to figure out which one's right and which one's left. All of these should be respect to y. Oh, 7 and 8 are regular. Yeah, you can take 7 and 8. That's on your calculator. No, it's 10. 9's not on there. 10. No, 10 you do left to right. I mean, you could, but you wouldn't. If you do left to right, you don't have to split the bounds up. You see what I'm saying? If you do it the way it is, you'd have to do from 0 to 1 of x squared and then from 1 to 2 of the other. But if you do it with respect to y, then you'd have x equals the square root of y, and you'd have x equals 2 minus y, and you could just do the integral from 0 to 1 of this one minus that one. And the farthest right on 3, the right one would be the y squared one. The left one would be the y cubed. Look at the one that's closest to the y-axis for the furthest left one. Yes. If you do right minus left, you got to get x by itself. If you do top minus bottom, you have to get y by itself. Whichever, yes, you can. Some of them you could do it either way. Everyone I gave you is easier to do it with respect to y. On which one? 10. 10, if you did it with respect to x, you'd have to divide it into 2 different areas. Yeah, you'd have to do from 0 to 1 and then from 1 to whatever that is. Yes, you are. Yes, you are. We're into the thick of it now. That's why it feels like that. Is the thick of it?
No.
What? I'm talking about backyard again. I don't know what I mean.
Do you have a calculator?
Y'all are getting hung up on the easy. Look, 2y minus 1/2 y squared minus. What's in parentheses? Yeah, but if you're just subtracting here, is it going to impact subtracting if I drop the parentheses? Brother, I don't